Good morning, folks. This is Matt Rogers with Heat Transfer Sales, Hoffman Hydronics, and we're here this morning to do another best practices, handy tips for your pump installation and alignment. Why does installation and alignment need to go together? Because a poor installation is going to negate any type of alignment that you do on your base mounted pumps. As far as base mounted pumps go, which ones need to be aligned? All of them need to be aligned. There's a misconception out there that these pumps come aligned from the factory and don't need any more alignment. If you read the IOM on the front cover, it specifically states these pumps have to be realigned once they're installed on the job site. And to verify that, on the cover, it says this pump needs to be realigned after installation. Okay? The reason being that all of these components of these pumps are what we call malleable, which means that you can change the shape of them. You change it by stress, putting the pumps under tension. It could be stressing the casing by having overloaded pipe weight on it, by having it twisted, by having it under tension, by trying to jack something in or out, by having soft foot issues. By soft foot, we're talking about the situation that occurs whenever you have 4 attachment points and one of them ends up needing more shimming than the other. And as you pull that pump or the motor down, it ends up twisting either the motor or the pump, or the base for that matter. And that's why it's so important that we start with the A in our ABCs on our installation. First thing we want to do is verify that this pump is installed in a neutral situation. By neutral, we mean that this base is not under any tension. Once you start putting this base and any of these components under tension, you create an atmosphere for vibration. And vibration is going to slowly but surely pull all of these components back into a misaligned situation. Why is alignment important? Alignment is important because we're trying to maintain as close to a zero tolerance in these shaft alignments as possible to keep the friction points on these bearings at a minimal. The more out of line these shafts are, the more friction is created in the bearings because you have more surface contact area. What happens when you have misalignment is you have the bearings have more friction contact points, and so those bearings are going to end up getting hot, and that heat is going to cause the components to fail at a sooner point. Okay, so first things first, when we receive this pump, it's a good idea to do what we call a rough alignment. We want this pump to be situated so that it's in a neutral position with no tension on it. So we want to loosen all of these bolts to however it's attached to our base. We want to remove our coupler, and whether you're using the old Sureflex TB Woods type coupler or the newer Duraflex type coupler where you actually have your elastomer on the outside, you need to make sure that you're getting these couplers, the shafts, to where they're in basically a neutral alignment. So first thing we want to do is remove all of these bolts that hold this element, this flexible element, to the outside of these coupler hubs. And for that, you can use your impact wrench to loosen these. However, when we put these back together, we want to use hand tools. The reason we want to use hand tools is these bolts that hold these elements onto the hubs are zinc bolts with a serrated head on them. These bolts will shear if you put them under too much tension. So for that reason, we want to tighten these down until they make contact with our elements, and then just give it about 1/8 of a turn so that that serrated head actually latches into the metal of that hub. If you use your impact driver, you're probably going to over torque these bolts and stretch or break them. So let's use hand tools when we're putting them back together. On the Duraflex coupler hubs, these are CNC machined to a very, very tight tolerance. If you look at a set here, you'll notice that you can actually see and you can visually identify whether or not you have any misalignment issues going on. You can see the angular misalignment in them very easily. You can see the side and the top to bottom alignment issues if they're out of alignment. Whereas it's very difficult to see on the old Sureflex type couplers. But with these new coupler hubs, one thing to bear in mind is they have one set screw. That set screw is right over the keyway, and if you'll just loosen those and pull the hubs together, you can see what your base alignment is. This alignment from the factory is pretty tight, okay? We have a little bit of side-to-side misalignment. You can see that there's a gap on this side. The height is just a little bit off, but not much, but you can feel it. Okay, those things can be taken care of. But this, for a base alignment, is not too bad. What I like to do for my installation process is leave these hubs just like this until I'm ready to do my final alignment. Because these are going to show you any problems that you have during your installation. For example, we talked about a neutral installation, which means that this base needs to remain neutral with no tension on it once it's installed to your housekeeping pad. So when we mount this to our inertia base or to our housekeeping pad, we want to maintain this to stay in a neutral position. There are not any inertia bases or housekeeping pads that are totally flat. And because of that, installers have a tendency to crank these bolts down on this base and twist this base to end up matching the profile of that housekeeping pad or that inertia base. And in doing so, you throw this pump out of alignment. You put tension in it that's going to end up, it's like stretching a string and thumping on it. You end up getting that vibration, transfers noise, transfers movement all through your pump. We're trying to eliminate that. To show you the effects of it, if we just give this pump an artificial but very prevalent this much difference in the housekeeping pad and the base, and then we tighten this down, as most contractors will do, pulling it down to the pad. Let's watch what happens to this coupler as we tighten it down. You see how much misalignment we got out of this? If we look at it from on top, we're going to see the side-to-side misalignment has moved at least 20 thousandths. The height has grown substantially. The angle of alignment has changed. So all these alignment points have changed simply by putting this base in a situation where it's under tension. So we want to maintain that this base is neutral. So if we leave these couplers set up like this when we're doing our installation, when we attach it to our housekeeping pad, we visually get to see what changes we've made to it. And then through shimming underneath that base, we end up pulling our pump base back into a neutral position. We noticed that when we took the tension out of the base, that our alignment fell back into its neutral position. couple of things that you need to pay attention to as you're doing your alignment on it. One, we mentioned a soft foot. A soft foot is what happens whenever you have one point of contact on your attachment to end up being higher or lower than any other place. An easy way to tell if you have a soft foot is to go around where it's attached and loosen one bolt at a time and see if any of the shims move. For those of y'all using laser alignment tools, the majority of these laser alignment tools have a function on them where it will help you identify soft foot simply by loosening one bolt at a time. Okay, we have a little movement in these front shims, which tells us that we have a little bit of a soft foot on this front quarter of our attachment points for this motor. So before we do anything else with our alignment, we're going to correct that soft foot by using graduated shims, stainless steel preferably, to make up that difference so that our shims are tight under every loosened bolt. These are the graduated shims you want to be using. They're going to be stainless steel. They won't rust or corrode. And the effects of plastic deformation, which is the effect that anything has when you compress it together of it changing its shape or changing it dimensionally, is very minimal with stainless steel. Don't use plastic, don't use paper, don't use wood, don't use brass or bronze or copper. Use steel or stainless steel for your shims, and make sure that they're sized appropriately for whatever you're trying to shim. For example, these are what they call a B-size shim, and these are pretty much a 2-inch by 2-inch shim that are set up for up to a 20 horsepower motor. Over a 20 horsepower motor, we're going to want to go to our next size shim, which is going to be a 3x3. And then after we get to a 60 horsepower motor, we're going to be wanting to use the bigger 4x4-inch shims. So appropriate size and material for your shims is important. Okay, another thing that you need to be aware of when you're doing these alignments. What I like to do, if I'm doing my base alignment, to do what we call a rough alignment, we're going to check all of these bolts and make sure that we're not going to be bolt bound in any way when we start doing this alignment. And by this, we mean that I can freely move my pump and my motor enough to maintain an alignment. You don't want to be forcing by trying to push the pump or the motor over with a crowbar or a wrecking bar or a ratchet strap pulled to it, trying to pull it under tension to try to get it to move enough to get it in alignment. Because if you put these under tension, they're going to try to fall back into a place where they're neutral. That vibration is going to shake these until they get to a point where that vibration is reduced and it gets under less tension, which is going to be in an unaligned situation. So if we go through and we loosen all of our points, we should be able to move the driver and the pump enough to find that neutral point of alignment without having to modify any of the holes, without having to change anything on this base. This ought to fall into a neutral alignment. And then as we tighten these bolts back up, we want to do it in a pattern so that we go one side to the other in a crossing pattern, and you want to do half torque, or snug, and then go back and do your full torque. If you don't know what the torque rating for your bolts are, typically on these 3/8 bolts that hold these motors down, It's a 3/8 standard grade 5 bolt. It's going to be from 12 to 15 foot-pounds of torque. If you don't know what that feels like, use a torque wrench. Practice with that torque wrench until you feel what 12 foot-pounds of torque actually feels like, and you'll develop muscle memory. Then you can put your torque wrench away and trust your feelings. Okay, tightening down the foot on the bearing frame. A lot of people just willy-nilly come in here and just tighten these bolts down. One thing you need to realize is that if you do this and you don't have a sequence of tightening this, you'll end up creating a pull-down effect with this foot that's going to cause you tension in your bearing frame and also cause you some misalignment. The correct way to do this is to loosen all 3 bolts up until it's loose. Then what you want to do is you want to snug up your feet so that it pulls the bracket down to the frame. You want to tighten your bolt on the bearing frame up, and then you want to loosen these bolts again. And then retighten them. Because as we tightened this bolt, it put tension on this bracket and will actually pull the nose of this pump down. So verify that all your bolts are torqued correctly and that you have a good rough alignment before you go on to your next installation phase. Now, once we've got this pump sitting on its inertia base or the housekeeping pad, we verified that the base has stayed neutral and it has no tension. We shimmed under it accordingly before we fastened it down. We want to make sure that as we start adding our components, for example, we're going to put a suction diffuser on the front of this pump more than likely, and then you're going to have your discharge piping on top of it. We want no overhung weight on this pump. This cast iron is extremely malleable. If you put too much overhung weight on the front, you take a chance of, you will absolutely bend the casing. You'll throw your center lines out for your impeller and your wear rings. Your seal faces will not line up anymore. Your bearings are going to be under tension. So we want to make sure that this remains neutral. So when we install that suction diffuser, we're going to pay attention to that coupler to make sure that nothing is changing our alignment on that coupler. We're going to have a suction diffuser stand under the front of that suction diffuser, and its sole purpose is to support the weight of the suction diffuser. It's not to support any pipe weight. It's not to change the angle of approach when you're doing your alignment. In fact, if you have a horrible situation with your angular misalignment on a pump, the first thing you should check is to see if your suction diffuser support is actually being used as a jack instead of as a support. So we want to make sure that this is just snug up to the bottom of the suction diffuser, about a half a turn so that it supports the weight of it, and then lock it in place. Any pipe that's attached to that suction diffuser, we need to make sure that it is neutral and has no weight on the suction diffuser or on the discharge side of the flange. To do that, you loosen your pipe connections and verify that you can get a 5/1000 feeler gauge between your pipe connections. A dead giveaway that you have weight on your piping, on your pump, where your piping is attached, is look at your flex connectors. If your flex connectors are bowed out or twisted at all, it means that you have some excess weight that's pushing down on the pump or on the suction diffuser, and we want to minimize that. Another key point is when we attach our conduit to the motor, we want to verify that the conduit is not putting tension on this motor, constantly trying to pull it out of alignment. So it's important when we do our final alignment that all the installation processes have been completed. The only thing left to do after this pump has had its final alignment should be to grout the base. Grouting the base is the final step, and an important final step, because what that grout does is it creates a solid mass that absorbs the vibration and will hold your alignments in check. So number one, eliminate all of your tension out of your base. Do rough alignments. Make sure you don't have overhung pipe weight. As you're doing your alignments, make sure that you verify that you don't have any soft foot situations going on. Correct those early in the alignment process. As far as moving the pumps and the motors, never just take a hammer and smack it on these couplers to try to move the pump or the motor. What you're doing is you're slamming those bearings, the ball bearings, against the race, and you're creating dents inside that race or on your ball bearings that are going to make the bearings fail. Never hit these shafts with anything. No force on these shafts. If you have to move this motor or this pump, we can use a couple of different ways. One, you can simply take a pry bar and move it by having it against the base to move it. Lots of leverage points. On the motor side, we can put a lever underneath the feet, and we can simply lift up as the bolts are loosened, and it will slide the pump over. If you have to hit on the pump or the motor, make sure you're hitting on the feet and that you're using a drift that is a softer material than what you're hitting. I suggest using brass drifts. And by a drift, we're talking about a solid object that we can place against the foot and then use a hammer to end up moving the pump or the motor. Like I said, never hit the couplers, because these couplers are attached to the shaft, attached to the bearings. All that impact is going directly to those bearings. You're taking a chance on failing. Okay, we were dealing with base mounted pumps. Now we're dealing with a close coupled pump that has no base, but the effects of overhung pipe weight will result in misalignment of these casing components, just like it does on a base mounted pump. So we want to try to keep this base or the pump casing neutral, just like we did the base on our base mounted pumps. The way that we do that, we support all our piping so that we have no overhung weight, and we make sure that our suction diffusers have a support underneath them to support the weight of the suction diffuser. Because like we said, all these components are malleable. We can change the shape of them just by force or putting them under tension. And when we do that, we throw all our center lines off on our components, and nothing's going to wear or last as it should. All right, as we've completed our alignment on this pump, a couple of things that you need to pay close attention to when you reassemble this coupler assembly. One is that they only have a single set screw, so that when we put the set screw back in place, we want to tighten this to what I call dig in tight, which means it's tight enough that it actually digs in to the shaft, or in this situation the keyway, to make sure that it doesn't move. Because if these are not tightened appropriately, these couplers are harder than the motor shaft and the pump shaft. The coupler won't fail. It will end up wearing out your pump and your motor shaft, which are very expensive to replace. Another key thing is when we reinstall these couplers, we want to install them so that the keyways are opposite of each other. This helps with the final balance of the coupler. Here again, using hand tools to reattach your coupler elements. Because like we said, these are zinc bolts and they will shear if you're not careful. So we've got them snug, and then that 1/8 of a turn so that they dig in. Always verify that you have at least 3/16 space between your shafts. This is important because as the pump and the motor heat up during operation, these shafts are going to grow. If you don't have enough space between these shafts, they will end up touching each other. Another thing, if this pump is installed or stored for any period of time before it gets put into operation, do yourself a favor and rotate these pumps once a week. Just walk around to each pump and spin them so that you make sure that the wear rings are not getting locked up by rust inside the casing, and that you're not creating flat spots on your motor bearings. So this is the basics of your installation and alignment. I hope we've given you some good pointers here, and we'll see you the next time around.